Okay, this is Raimo Kantola. I see my face on the uh, screen, so probably you see me too. So I'm a professor of networking technology at Aalto, the Department of Communications and Networking. My recent work has been in the context of 5G, and I have been focusing on cloud-based security and trust for 5G and other use cases and technologies. You see here a link to my project site where you find more information about the work that we carry out in our group. So I'll talk about what does a mobile network offer to the end device, what is the timeline for 5G, why is 5G needed at all, and what does that offer compared to previous generations. And then there's the research interest is larger industrial use cases, so I'll talk something about that. And then about some of the challenges that, first of all, relate to the regulation. So what does the mobile network offer? It offers a virtual wire from the device to the edge of the internet usually, or another packet data network through the mobile network. On the way, you have the air interface and you have the packet core. So a device cannot communicate within the mobile network at all with another device or anybody else for that matter. And this applies to 4G, 5G. In 3G and 2G, we had this circuit switched telephony service, which allowed two mobiles to talk to each other using just resources of the mobile network. But when it comes to the packets, this is a virtual wire service from the device to the edge of the internet normally. There is also a device-to-device in 5G, but this is an exception. No network is largely involved for carrying the communication stream from the device to the device. There's some control by the network, but that's all. And then what is remarkable about mobile mobility and mobile networks is that the value of mobility to end users is very high. Anytime and anywhere communications is really great. We have got used to it and we want to have it all the time. The great feature of mobile networks is that it authenticates its devices and users, and actually mobility per se is not really possible in a public network without authenticating the users. Another great feature of mobile networks that the device can roam between networks. For example, a Finn having a mobile subscription from a local company, for example, Elisa, could be visiting China or Australia or the United States. There's a roaming arrangement with the local operator, and as a result, also the mobile operators, they form a family in a way, and they have a great level of trust among themselves. So the timeline for mobile generations. First of all, the concept of generation. What is that? First of all, it is a marketing campaign. And then each time we have had a new generation, new frequencies, radio frequencies have been introduced and allocated to mobile service. And therefore, new devices and new base stations have been designed and sold to companies and to end users and consumers. Each introduces a leap in bandwidth and features and in terms of what one can do with the service. About 10 years is the distance in time between the different generations, from the second generations, which was the GSM, and then the third one, and 4G, which we currently use extensively. And now we are in the year of introducing the 5G services in in many countries, and if they are not being introduced, then it's in the very, very near future. The concept of a generation is unique to mobile networks, and it has helped to pace the development and get everybody play the same tune, which helps technology adoption. And as a result, we have been able to introduce new technology faster. So this is a great learning from the mobile experience. So 5G sounds like, yeah, it's going to service this year. But actually, what is happening is that the technology is being further developed by the industry. And the features are 5G are introduced in releases. Now we are talking about release 16, and then there will be release 17, and so on. The count of this generation starts from the history of 3GPP and mobile services. So numbers are big already today. What we are talking about today in 5G is the enhanced mobile broadband, enhanced compared to 4G. And there are two modes, 5G at the moment on the table. One is the non-standalone. It means that for control and signaling purposes, the 5G network will use 4G. So there needs to be a 4G frequency available for the operator. And it must have a 4G base stations spread across the country. And then on the side, they can introduce 5G, which offers greater speeds to the end devices. And then later on, or as we speak, there's also the standalone mode. And some devices are supporting standalone already today, but quite few actually. Same goes with the base stations. But within a year, I think we are having that as well. It means you can independently work and provide services independently of 4G. Then the second great use case for 5G is the ultra high reliability and low latency communication service, which is meant mainly for vertical corporate markets, for specialized networks, private networks, but also for public networks are used for a wide area community kinds of services. Then a great feature of 5G is this network slicing. It has raised a lot of enthusiasm in the industry, and we'll talk more about that as we go. All right. So although a commercial service is starting, it doesn't mean that the technology is ready in all aspects. Rather, in terms of research, the interesting stuff is just happening, and there are still new things that we need to learn and create in 5G before we are happy that we have used the potential that is embedded in the 5G technology. Now, the major use cases, this is a slide from Tomi Uitto, head of Nokia now. He used this a couple of years ago. So we have the massive or extreme mobile broadband use case at the top, which means that the mobile service to end users and consumers provides faster connectivity, lower delay, more capacity to the operators, and so on. This, for example, replace wireline services at homes because of the quality of the service that is provided to consumers. Then there are two other major use cases for the whole technology. On the left hand bottom corner, we have this machine-machine communications, which allows to connect low power devices to 5G networks, and millions of them per a million devices per square kilometer. So in terms of scalability, the technology is much better than the earlier generations in that corner. Then for vertical markets, an important corner is the right bottom corner, where we have critical machine communications, where latency is very low and ultra high reliability is provided. These services are quite expensive compared to the extreme mobile broadband because in order to reach ultra high reliability, more radio resources have to be consumed. So providing all these at the same time is not on. It's not economically feasible. In this corner, bottom right corner, we are doing quite a lot of research nowadays. For example, imagine that you have container lifting machines in harbors, and we would want to drive them remotely from the office. This requires several video feeds from the top of the moving platform, and it requires haptic device, whereby the driver sitting in the office can, with precision, control the movements of this moving platform. This is just an example. Then the operators in mobile networks and also in wireline networks, you see the legacy problem on the left-hand side, right? Where they earn their money. The data is growing moderately, voice is going down, and the total volume of revenue in the industry globally is not really growing. It's flat over the past few years. Now, because of Corona, there might be some changes, but not a big one. Then, if we look at the same years where the new value from the internet has gone, it's in things like cloud-based advertising, it's in business processes as a service, software as a service, and cloud infrastructure as a service. Also, things like Netflix and other video on demand services have significant revenues. Okay, so there is new value, but this is really not going to telcos. It's going to cloud services providers, and some of these, or majority this money is going to global giants such as Facebook, Google, Amazon Web Services, and Microsoft. All right, all American companies in the Western world. In China, there are corresponding companies to these ones. So we can see that in the world we have maybe 2 or 3 regions, and on each of those regions we have a small bunch of cloud services providers who earn lots of money from the internet. The motivation of the industry behind 5G is explained on the right-hand side, where we see the estimates of markets where we see growth, where 5G could be used. It's things like factories, it's like harbors, cities. We talk about smart cities, logistics and transport, very clear use cases where we are moving vehicles, and we could serve those much better with a better and more reliable radio technology. And finally, then there is this case of e-health. What is the potential there is uncertain, but expectations are great. All right. Let's move on to the technology itself. So I'll talk briefly about 5G principles, what kind of technology we are talking about. First of all, the core network in 5G is based on software-defined networking. This is a new principle which separates the data plane and control plane. Such a separation, for example, does not exist in the internet. So the data moves on in the data plane, and then the network has a control plane to guide the movement of users' flows, data flows or packet flows. And this data plane is handled by the SDN switches of some type, and then in control plane, the operators have their virtualized network functions. A virtualized network function is a software that runs, for example, in a virtual machine or in a container. So at the bottom, we might have a virtualized Linux, and then we emulate computers for each of these functions. And as a result, the software is detached from the hardware. Generic cloud technology platform is used to run the network itself. Okay. Then a great feature of 5G is network slicing. A slice is a set of resources that the network allocates to a use case. And for this use case, then we can tailor the network. If we need a higher level of security, for example, yes, we can add that into the network. If we need quality of service better than the normal best effort service, we can put more resources into the slice and tie them to the users of the slice. And then the SIM card on the device, it allows attaching to a slice or several slices for that matter, right? But if there is no permission, then that device cannot attach to a slice that is out there. If there's, for example, a slice for some priority services for rescue purposes, then the consumers cannot interfere with the rescue services. And then provisioning the network by the operator can be used to assign transport capacity to a slice. And then setting up a slice in 5G will take minutes rather than days or hours or whatever like that. So it's very flexible way of providing services and allocating needed capacity for that purpose. Then a great important feature in 5G is low latency, which is significantly better than what we can do in 4G. In 4G, we talk about tens of milliseconds to about 100 milliseconds delay. It's variable. There's a lot of jitter in this respect. Jitter meaning that the delay varies or latency varies over time. So in terms of like a bit rate, 4G is okay for consumers, but in terms of this variable delay, it's not that okay for all users. For example, net gamers do like 4G at all. They take ADSL wireline services any day because more predictable service. So it's like if you play a shooting game, you die in 1 in 10 battles if you use 4G, but if you use ADSL, you stay alive, and therefore the gamers do not like 4G. We believe that in 5G we will be able to reach the level of service also in this respect that is provided by wireline ADSL services. So the copper at home be replaced by 5G in the last mile. Also, we can do augmented reality services, virtual reality services. If you use 4G, then users become dizzy. This has been tried, it doesn't work out. Haptic control interfaces, for example, for remote driving in 4G, that will work poorly. It's like driving a boat as compared to driving a car. We have lots of control loops in industry where information is transmitted, and some of these control loops require low delay. For example, we are studying the case of smart grid, and there we have seen this kind of loops where it's absolutely necessary that delay is kept low, in the order of like a millisecond or less, or a couple of milliseconds, but not the kind of delay that 4G can provide. And if this is not done, then simply this 4G technology cannot be used and is not used for certain things in smart grid. Okay. So why is high bitrate then important? Let's be realistic about this. It will be more economic to build high capacity in big cities because of this feature. So the cost to mobile operators can be checked and kept low, even if we provide a higher and higher capacity to end users. An individual user like myself, I could download my morning newspaper faster. We could provide service to homes that is comparable or better than ADSL. So remote work requirements will be easier to fulfill, like because of Corona now, lots of people are working at homes, and it requires also video like we are now using at the moment. And new services like the all kinds of augmented, enhanced virtual reality, those will need higher bit rate. But sort of the highest bit rates that operators use to advertise their services are really important, because if you, for example, take a smartphone in 4G, it is limited to, in terms of what it can consume, usually to less than 10 megabits per second on average, right? This is average. There might be peaks when it can consume more. If we compare 5G with the internet, we see that these technologies are quite different. In the internet, the service is less effort. Internet as a concept does not say anything about how the access is provided. 5G is all about the access. Instead of best effort in 5G, the network is tailored to a use case. This is a high-level industry approach to what the 5G network can provide. User identification. Actually, there is no user identification officially and formally equally the same for everybody on the internet. But nevertheless, Facebook and Google know everyone in the Western world. But at the same time, they do not know who is the sender. So the picture of identification is really messy on the internet. In 5G and mobile networks, it is very clear. Users are identified by SIM cards, and there's authentication. User is always known. And this is a must-have feature, because if we did not have this, then anybody could tell, for example, where I am, and this is completely unacceptable. So then the mobile operator would not know whom to send the bills for whatever services are being rendered and used. So there must be authentication, and this is a great feature of mobile technology. Then security in 5G is quite decent, while on the internet side it's quite poor. There are lots of technologies on security on the internet side also, but still lots of hacking takes place. And all kinds of devices that have a very poor security can be sold to consumers, and the network operators cannot do anything about it. Okay, but when then bad things happen and there are DDoS attacks, denial of service attacks against critical services, then usually somebody tells the operator to do things and sort of take responsibility for the security that was where the problem were caused by other people. So why do we tailor the network to use case? Very briefly, the reason is that we cannot provide all these great features, high reliability, high bandwidth at the same time. It's just way too expensive. So then what we instead want to do is to separate the use cases and then put a use case to the kind of a slice where it will get the resources that it will need. Okay, the price tag might be different, but if the network and the use case are important enough, then we will find people who are willing to pay for the service. Then at the same time, let's recall that there's this internet regulation, for example, in the European Union. It's called net neutrality. It applies to internet access services, which means that there's a consumer trying to do something over the internet. And this regulation says that all packets must be treated by the operator who is providing internet access service in the same way the sender, receiver, device, service, application. And this is called either the open internet or net neutrality. So this is very much against the idea of tailoring the network to a use case when consumers are involved. So a challenge is that there's a conflict between internet regulation. So the 5G network is virtualized in terms of software. It runs on cloud platform. And also in the network, we have compute elements. So mobile operator will have to own a cloud platform because the software is virtualized. But then also, in addition, that same platform provides compute elements for end user services. But if the service is under net neutrality, then actually it can only run one program in the compute element, and every service must be treated the same, which is really not reasonable at all. So when it comes to consumer, cannot take full benefit of the technology under this kind of net neutrality regulation. So in my opinion, then net law in European Union is a hindrance of best use of 5G compute elements, and this creates uncertainty and slows down investments because majority of the money in 5G also from the beginning will come from the consumers, and if consumers don't need something, then why would an operator invest into it? How we can solve this dilemma? There are several approaches. We could deregulate the telco cloud in some way and under certain constraints, and then basically the capacity in the mobile network cloud could be sold to, say, over-the-top providers such as Netflix, for example, which at the moment is not possible, not allowed in Europe. This the compute capacity could be also sold to consumers and allow them to run their own software on it and say that that software is not under net neutrality, and what the users do with the capacity that they have been allocated by or they have bought from the mobile operator. It's their own business, right? Okay. So there are approaches to overcome this conflict, but whether this will happen or not, it's open. There's an ongoing hearing about this in Europe, and maybe within this June, the regulators will tell what they are going to do about this. And why is solving this dilemma important? Achieving low latency requires local compute capability, because if it's not there, then providing ultra high bandwidth will be expensive to the mobile network operator. It will need a very high bandwidth connection to the internet. But if it has the local compute element, it can optimize those services, and less bandwidth will be connected to the internet. And basically, for these reasons, then this regulation is pushing some of the 5G functionality to the hands of such companies as the Amazon Web Services, Facebook, Google, and what have you. Okay, so mobile operators will build something, and these guys will earn money, and they are global giants and almost near monopolies. 5G will be used for critical infrastructure. So physical safety will depend on high level of security. So physical safety, meaning people either die or they don't. So this is pretty serious stuff. We are not talking about stealing information or disturbing legitimate services, but we are talking about people dying because of lack of security. So in these critical infrastructure cases, or for these cases, it's very important that we improve the level of security, particularly when it comes to mobile services, but hopefully also for the whole internet. So this could be done by doing what I have been working on for the past 10 years, providing security services to consumers and whatever devices you connect to the network from the cloud. Okay. A new battleground is emerging between the digital and physical worlds. And this is visible, for example, in the controversy between China and the United States at the moment, where in the middle of this controversy, you have a company providing 5G technology, Huawei, you know about this, and sort of instead of being a matter of national politics, mobile networks, because of 5G, have become or been brought into the center of attention in international big politics. Okay. So, and I believe that this is because of the blending boundary between the digital and the physical worlds that is happening due to 5G. Who can hack this interface? Who owns the data that is on that interface? This is a big deal, right? Because by having access to that interface, to things like the smart grid, or the support services that relate to automatic driving cars, self-driving cars, or whatever, things like that, or e-health. If the foreign intelligence agency had access to all that, then less and less it would be necessary to send tanks to the physical border of countries. Instead, you could just hack their systems and put the country on its knees and ask them to do whatever you want them to do, or threaten that if they don't, then this will continue or will become worse. My advice on this battleground, first of all, it's like an immediate measure, is do not connect everything to the internet. layers of fencing for security are needed, and we cannot provide that on the internet with the internet principles. Then we have the question of impact of net neutrality regulation on industry structure. This net neutrality regulation that is currently in force in European Union is great for Facebook, Google, Amazon Web Services, and they have almost religious favor sort of defending this state of affairs. At the same time, this regulation ties the hands of European big players like the mobile network operators in the battle for cloud services, and this is also bad for companies that provide mobile services like Nokia and Ericsson. At the same time, China does not suffer from this kind of regulation. So, for example, for Huawei, it doesn't matter one way or the other. Network slice. So this is a bigger deal than VPN, a virtual private network. A virtual private network has a single customer, but a slice could have many customers. It could span even multiple networks. So this covers the in 5G the communications between device and packet data network, be that a special packet data network or the internet. If needed, we can have radio frequency transport and other resources, computing resources allocated to a slice. And because these resources are controlled by the software-defined network concepts, these resource allocations can be dynamic and change over time. Imagine rescue services. Sometimes they need quite a lot of resources where something bad happened. In other parts of the country, they would not need resources. So those resources could then be allocated dynamically within minutes or even fast. And then network software support can be added on top of the standard network functions in a slice, right? Extra reliability, extra security, extra interfaces for data collection, and whatever we can imagine. A slice needs a significant business case. We don't, for example, I have seen papers where people say that let's do this, for example, for Facebook a slice. I don't think that that kind of thing will work. These over-the-top providers such as Facebook will pay for it. Why would they? Okay. And also, in terms of the net neutrality regulation, it would not be allowed. Okay, let's summarize the business cases and the interests of researchers in 5G. So for consumers, first of all, there's mobile broadband, and with 5G we can do the level of mobile broadband that is equal or better than the fixed broadband. It's anywhere, anytime, at homes, like broadband to the home. We can do that in 5G. All these net neutrality troubles relate to this case. Then we have the vertical. This is new as compared to the previous generations. And the previous generations were optimized for consumers. Now, 5G is generic, and it can be tailored to the needs of these vertical markets, say logistics, harbors, or automated driving, or e-health. We can tailor the network for these needs. Okay, so there are actually quite a lot of cases that are out of scope for net neutrality, and we can go ahead with the 5G development, although it would get a boost if the telco cloud would be deregulated, as I have been advocating. Factories, warehouses, harbors, hospitals, health sector are good examples of vertical use cases. And for each of these use cases, we need the research and innovation because lots of this stuff does not exist. And each vertical use case has its own ideas and its own history and its own practices and its own needs. So that's why 5G has been much more interesting for researchers than some of the previous generations. Okay. Then we have a new wide area societal needs like support for automated driving, which needs accurate location information. So we could do that in 5G. So the goal of automated driving or the use of the network, goal for the use of the network would be to dramatically reduce the number of road accidents that take place and sort of how many people die on the roads across the world. Okay, so this was my story. I don't know whether there is a possibility to ask questions. That would be okay if it's organized by the course. I'll stop sharing and leave the floor to the organizer.